First off, I want to welcome everybody for showing up. How many of you are familiar with what an ABI is? So an ABI, for Algorand's version of the ABI, stands for Application Binary Interface, and it's a specification designed to easily allow smart contracts being used within layer 2 apps like dApps and wallets. And if you didn't know anything about it, if you've developed smart contracts for Algorand today, you realize that once you deploy the contract, the only way someone knows how to call it is if you tell them or they actually read your code, which the ABI is directly trying to address. So it's a specification that's being developed. And it's not only a specification for developers wanting to use smart contracts, but it's also a specification for developers who want to develop things like SDKs and internal tools like that. So it serves dual purpose. And in addition to that, as part of the ABI specification, we expect additional specifications to be built on top of that. All right, so my name is Jason Weathersby. I run developer relations at Algorand, and I've been here for 3 years. Before we launched on mainnet, it's been a great experience. But from an agenda standpoint, these are the things we're going to cover today. I'm going to try to keep it simple and sweet, show a few examples, but I'm going to cover a high-level overview of the specification, talk about using the ABI spec with goal, and then using the SDK in an ABI compliant manner. And then finally, I'm going to discuss from a smart contract developer, what do you need to do on the back end of your contracts to make them ABI compliant? And I'll also give you some things that we're still continuing to work on. Just so you know, everything you're going to see today is still a work in progress. We expect the ABI spec to be the SDKs to be built with ABI capabilities by the end of the year. That's what we're shooting for. PyTeal being updated in the first quarter of next year. So that's the current roadmap plan for that. So that's what I got from a standpoint of agenda. This is, if you follow any of the Algorand standards, they're ARCs, and this is ARC 04. If you download the presentation, you can just click the link, it'll take you right there. The whole specification is written up. What is the spec designed for? The spec is a specification for interoperability between smart contracts and dApps. Okay, it defines a standard for invoking the methods. It also defines a standard for encoding the parameters, what parameter types can be in there, and then how do you encode and decode return values, okay? In addition, it allows you to create, it also defines a JSON specification for how you make these smart contract calls. These are JSON artifacts, and we'll get into each what's available in those artifacts shortly. But then also, today we'll be covering how the SDKs consume those artifacts, how you can use them from the SDK standpoints. I'm also going to point you to more examples that you can look at after the talk's over with that cover, we got many examples in Python and JavaScript already that you can start looking at and start playing with. All the examples you'll see today, I'm running on Sandbox in dev mode, and I'm also, so I'm not have anything on the wire, so hopefully I won't get disconnected. Okay, so let's start off with traditional development of Algorand smart contract. I write my contract, I'm in development. Next thing I do, I deploy it to the Algorand network. Now, the problem with this is once you've deployed it, the only way someone can understand it is they have to go interrogate that contract, pull the code down, and read it. Well, this gets much more complex if you write it in PyTeal, and it's been compiled to TEAL, and you push that up, and you have this automatically generated TEAL. Very difficult to determine what methods are available. So as part of the ABI specification, we define these JSON artifacts. And as you're developing your contract, if you follow the format in the spec and write your ABI contract out into an ABI JSON artifact, then later on, that artifact can be used to call it. If you don't have this, like I said, no one's going to be able to find the methods in your contract. So looking at it I have a deployed contract that's sitting out on the Algorand blockchain. I got a wallet app, a dApp app, all in the deployed environment, right? All right, so what they do is then they read up this ABI JSON artifact. They know exactly the way to invoke your method, how to encode the parameters and all of that for you, okay? And in fact, the SDKs do all that work for you. And you'll see how simple it is in a minute. And then you also know how to process the return value. And what you're going to notice is we have many ABI types. They can either be static or dynamic, and you'll see what I mean by that and why that matters. but it gives you a lot more capability. Okay, so let's talk about the ABI JSON artifact. The spec defines a JSON formatting for these artifacts. There's a set of invocation rules associated with how do I call this contract. And then it also specifies arguments and return types. And then it decides how those are encoded. And then finally, we define 3 top-level artifacts depending on what you want to use. The first artifact is called a method artifact. All it has is an ABI method. I want to call one method on a smart contract. That's an ABI method. Then we also have an interface, which is essentially just a collection of methods. And then we finally have a class JSON file, which is basically a concrete implementation of a smart contract that has the full spec of functionality that's available to that particular smart contract. Okay? None of this is mandatory at all. You do not have to use the ABI. But if you want to use some of the SDK functionality, like the new ABI composer, then you have to be ABI compliant. And if you want to use some of the new features on Go, you have to be ABI compliant. So it's highly recommended that you make this capability into your smart contracts. Okay? All right, so all right, there we go. All right, so let's start with the method JSON. This is what the interface looks like. You'll notice we have a name, which is required. Then you have a description, which is optional. You don't have to put the description. And then you have an args, which is just an array of arguments that you can pass to it. It's name, type, and description. The only required one is the type. The ABI needs to know the type of data you're dealing with. And then so you can have just an array of arguments, and then you have a return type, which is a string, which is a type, and then an optional description, okay? This is an example of one. Look, this is an add method. Now I got a pre-deployed contract that has a bunch of math functions already in it that are ABI compliant. This would be me calling the add ABI method. I'm passing 2 uint64s and I'm returning a uint64. All right, so if you're writing an ABI, if you're writing the spec for, if you're implementing an ABI method, some of the rules that you need to be aware of is method name should start with a letter. And then you can be followed by any number of characters, letters, numbers, or underscores. But it should start with a letter. Camel case is preferred. So we prefer you to do it in camel case. And what's nice about this, the way we do these interfaces, the description, nowhere in the ABI are you really using the description when it goes to the smart contract, but it's available for wallets and other apps to display in a UI. So it's very UI-friendly spec. So you can expose that kind of the features and functions to the layer 2 apps. And what this is really nice is if you define something in a certain way, and all wallets adhere to that particular way, this is what I mean by standards on top of this one, then you'll get get something like if you think about ERC20 token or something like that. Okay? That's what the ABI method looks like. Now this is what the most important thing in the ABI spec is method signatures. And what are method signatures? Well, I have my JSON artifact, my method JSON artifact. I read that up into the SDKs. It produces what we call a method signature. This is a concatenated version of the JSON file that's basically just the required pieces of data. So we have our method name, an argument types, and our return type. Okay, that's all encapsulated. Well, another thing the SDK does, it does a hash of that string. Think of that as just what we call the method selector, method signature. Just think of it as a string. We take the hash of that, and then we take the first 4 bytes of that. That's called the method selector. That is what the ABI calls your smart contract with, okay? And you'll see this all through this presentation. Method signatures and what types can go in them determine a lot of things that the ABI will do for you, okay? Here's an example. The add method signature looks like this. If that's hashed, this is the hex value I get for that. And the first 4 bytes is the selector. So it'll look like this. Make sense? Shake your heads like this if it does. Okay, thank you. All right, so moving on. An interface is very similar to method. All it does is add a name field and it's an array of methods. So the same ABI method is inside this interface. Here's an example of one, my interface, and it just has one method called add. It's just the logical collections of methods. This is where the standardization will come into play. If I want to create a new arc with a new standard on top of ABI, this is probably where I'm going to start at, okay? Each method has to generate a unique selector. You cannot have the same selector. And if a smart contract implements these methods, then it's considered implementing the interface, okay? That's the interface JSON file. Then we have the contract JSON file. So what is it? It looks just like the interface, except it adds one extra field. It's called app ID. This is a concrete implementation of a contract. This contract exists in the wild, okay? And so, for example, here, app ID 123, got the method add. All right, it's like I said, it's similar to the interface, but allows, it's pointing at a specific contract. Each method must generate a unique selector, just like an interface. And it's when you do this, though, the ABI spec says that you need to, if your smart contract does this, you need to list every method that's exposed to the public outside of your contract. And so you can think about it as an interface. You can actually implement an interface and add additional functions using a contract. Okay, so those are the three, let me see if I can get this. Okay, yeah. I was going to say one other thing too is it's part of doing this. If you ever did an opt-in or opt-out transaction from a smart contract, if you have, you have to call a specific contract, a specific transaction to do that. One of the things with the spec allows, it has a special underbar opt-in, underbar closeout method. These are the only ones that allow the underbar to start with. Those are reserved. And what it allows you to do is call any method in the spec and add a field for that to automatically opt in or opt out as part of that call. And it does that for you. If you do not set this and someone calls your method and you use local state, your method will fail. So you have to set that. And the way you would do that is just use there's a field you can set on any transaction that you add called onComplete, and you just set it to this particular value. That's for an opt-in, and that's for a closeout. Now, if you don't, I don't know if most of you know this, but if you don't use local state, you don't need to opt into smart contracts. It's available just to use. Okay? Okay. All right, so from a standpoint of you have this method signature. What are the types of the method I'm allowed to put in a method signature? Well, we got a bunch of different types. First off, we have uints. These can range from a size of 8 bytes to 512. We got bytes, bools, addresses, strings, fixed decimal points. And a unique one is we have an unbounded type array. So I can say an unbounded array of integers or strings or whatever. Or you can have a fixed length array of strings or integers or something like that. Then we also support tuples in the spec. Now, if you're, and the nice thing about this is the manipulation of those data points is all done in the SDK for you. There's one thing to also notice inside of the types. If you use, there's two high-level types, static and dynamic. If I tell you it's a uint 8, it's going to take up 8 bytes, right? If I tell you it's an unbounded array of uint8, you have no idea how much space that's going to take, right? That's called a dynamic type. Anything with a dynamic type will always be prefixed in the argument or the return type with a 2-byte signature for how long, length of that particular arbitrary piece of data. Okay, so if I have an unbounded array of 2 elements that actually get passed, then we're going to have 2 in the first 2 bytes, so the value 2. All right, so that's called a dynamic type. And it'll be very important from a TIL standpoint later how you deal with a dynamic types when we get to the back half of this presentation. All right, another thing you can do in a method signature is you can actually pass foreign types. And what are these? You can pass an account, an asset, and an application. Well, if you've written any smart contracts, you know about the application array, the assets array, and the accounts array. This allows you to add extra data into the call so the smart contract can access more data. So these are essentially mapped to those arrays, but you can actually put those in your signature. So you can say, okay, with this particular ABI call, I have to have an extra account in there that I need to go read. So you can write that into your signature. So that's called a foreign type. That can only be passed as an argument, no return type. And the other type is, let's say, has anybody composed an atomic transaction before? you know there's a lot of effort that goes along with that, right? So one of the things that we have now is as part of the method signature, you can actually put a special type, and that can be any of the 6 transactions Algorand supports or a generic just transaction. So what this does is I can say, oh, I want a payment transaction to go along with my app call, and you can enforce that through the method selector. So if the method selector doesn't have it, then you go, okay, this call doesn't match, and I'm not going to execute that call. And so when you're dealing with atomics, that's typically one area we run into a lot of issues with people doing development. All right, so from a method invocation standpoint, the spec is designed to, and the SDKs implement this, is basically invoke the method. And the way they do this is, after it generates that method selector is put in the first parameter spot, okay? The SDKs in Go handle this for you. You don't got to do anything special to do this. Then you can do up to 14 parameters after that, and if you can actually do more than that, up to your 2K limit. But the SDK underneath will convert anything over 14 parameters to a tuple in the 15th parameter. So, and the SDK will parse that for you, and I'll show you that a little bit how that's done. But if you're writing handwritten TEAL, you're going to have to parse the extra tuples yourself using extract opcodes. Okay, and then finally, we have a new way of returning values. If you've been watching TIL 5, we got the log method. Well, one thing we've added is if you prefix it with we take the word return, we hash it, we grab the first 4 bytes of that. If you prepend your results with that and log that, that's actually what the ABI will use in its return value back to the SDKs. So you can do that same log message multiple times. The only one that will matter is the last log that you put in with that prefixed return value. Okay? So what does this look like from a high level? All right, so I read my method interface or contract or method or interface or contract JSON file into the SDK. We don't have this done yet, but we're most likely will be able to pass those into Go. You can pass a method signature into Go today, but we don't have consuming the JSON yet in the works. But you pass those into the SDK, they generate this method selector, either method, and they call the smart contract. And then what you do in TEAL, we have this new opcode called method. All it takes is a big long string that represents the method signature, and it produces the method selector. And this will be important if you're calling smart contract to smart contract as well. You want to generate your selector so you match there too. But you generate the method selector, and then you prefix your return with that 4 bytes in the log that I told you about. And if the 2 are equal, then you're going to execute that piece of code. One thing that's important to do though, if your selector doesn't match, make sure you put code to handle that situation. Because if you get an app call, no methods found, you want to at least handle that gracefully. Okay, so let me show you just a real quick example of just running it from Go. It's fairly simple. All right, so I got this little simple contract here, and all it is I'm taking that, it's called add. Here's my method opcode, and here's this method signature. That gives me my method selector. I'm comparing these two, see if they're equal. If they're not, I assert and the contract fails if they're not equal. Then I'm just beat I in both the second and third arguments and prepending this 4 byte return value and concatenate to it and logging out the results. That's how you just do the standard stuff. So from calling it from Go would look something like this. I am using Sandbox, so first thing I do is copy everything up to Sandbox, deploy the app, Go app create. This is what's new. Go app method. And so you call the app ID, and then you pass in a method parameter. And all you do is pass the method signature, and then you pass your arguments like you normally would. All right, so if I run this, all right, so I'm just deploying the Sandbox, and you can see it's going to return it calls this method signature, and it returns an output of 4. So I just added these 2 numbers, 3 and 1, and a smart contract did that for me. Okay, so back to the presentation. All right, so if we look at from a standpoint, if we look at it from a standpoint of the specification, when we bring these in, the SDKs are all the SDKs will have these 3 classes, One's called an ABI method, one's called an ABI interface, and one's called an ABI contract. These are concrete objects that you can use to manipulate each one of those JSON files once you read them in. So if you go, I'm going to show a quick demo of that. So let me switch over to JavaScript. All right, so let's say I'm going to show you 3 files real quick. I have a method JSON, which is that add method you saw earlier. You see what that looks like. I have an interface, and these were in the presentation earlier, and I have a contract. All right, so I can then go into, okay. Yeah. All right, so I can connect the sandbox here, like you've probably seen in examples before. And then what I'm doing is I'm just reading this file in, like method, and then I'm instantiating an ABI method right here. Well, then I got fields that I can call on it, like get selector, which generates a selector, get signature, which produces the signature for me. I can get its name, and then I can log out a description if one's available. I can also loop through all the arguments in it. Now here I'm doing the same thing for the interface, except I'm just dumping the JSON. And then finally here, I'm reading in a full-fledged contract. And what I'm doing is creating an ABI contract, logging out the name, the app ID, then I'm iterating through all the methods in that particular contract and just dumping them out. So if I run that, okay, so if I run this one, you'll see what the output looks like. All right, so all I did was just basically went through, there's my method, there's my selector, there's my signature, method name, and the description, and then the two argument types and the return type. Okay, there's the interface where I just dumped it, and then finally the contract where I just iterated through. It only had one method in it, so it just iterated that one. All right, so that was that. All right, now this is one of the beefiest parts of the new SDK for ABI compliance. It's called the ABI Atomic Composer. And what this is a ABI compliant way of generating either one or more transactions. If it's more than one, it creates a group. You can use it for standard payment transactions or any other transactions that we already do, but it also supports application calls. It enforces the ABI. That's the important part of it. All right, so it's part of the Atomic Composer. Inside of the Atomic Composer, when you instantiate one, it has a state machine that essentially tells you when you're building it, when it's built, when it's signed, when it's submitted, or when it's committed to the chain. All right, so as part of that, the composer has 2 method calls. One's called add transaction, one's called add method call. And then we have a function called build group. So it builds the group for you, and it moves the state from building to built. And then we have a gather signatures, which signs the transactions and moves it to signed. And then you can either submit it and return at this point, or you can use the execute method, which actually executes the method, waits for it to complete, changes the status to committed, and then returns the confirmed round, an array of transaction IDs if it's a group, and the ABI result, which is an array of ABI types that you can root through the results and look at what your smart contract returned. And so this has so much functionality associated with it. It handles all that encoding rules and decoding rules when the smart contract is coming back, and we've used it several times. It's fantastic. Okay, so I'm gonna well, not next slide, but it'll be coming up. Just hang tight. All right, so if I have the Atomic Composer, doing a simple transaction is no more than add transaction. Okay, and what you pass it is what we call a transaction with signer object. You give it a transaction and a signer. Now, so in the case here, we have the transaction signer. The signer can be one of 3 types currently. We have maker functions for basic account signer, make multi-sig account signer, and make logic sig account signer, which should map to the current way you're basically signing transactions. But what's unique about the composer, all 3 of these implement this interface. And all it takes is the group of transactions, an array of them, and it indexes to sign, and once the promise is fulfilled, it returns an array, a uint8 array of all the signed transactions. If you implement this interface yourself, you can plug it into the signer field, and you're good to go. And just so you know, Wallet Connect will be making progress to implement that interface as well. So what's really beautiful about that is, if you've ever done an Atomic where you needed signatures from multiple places, it can be quite difficult. Once we have Wallet Connect capability in that, it'll make this much, much easier. So this is the transaction with signer, and both the add transaction and add method calls support this methodology. All right, so here's an example of what the code looks like. I make a payment transaction. You've probably seen that if you've developed on Algorand. It's the same way you would standardly do it. And then I create this variable called transaction with signer. I'm setting the transaction object in it and the signer object in there. Here, in this case, I'm just making a basic account signer. And then I'm adding that transaction using the add transaction call. And that's all there is to it. All right, now the add method call is very similar, but it has a few more fields. You have to pass in the app ID, the method you want, the method args, and the signer. Same kind of signer that you saw before. There's a few more parameters associated with these are the primary ones. If you look at here, this is I get my suggested parameters like I normally would. I pass in the app ID, the sender, the suggested parameters, and then a signer. And then I just call building a composer using the atomic transaction composer constructor. Then I do an add method call, passing the name method, the method name, and then the method arguments, and then those common parameters. That's all there is to adding that method call to the composer. All right, let me show you a demo of both those real quick, and so you can see what it looks like. All right, so this is a simple composer where I'm just saying, okay, I'm creating an atomic composer. I make a payment with a suggested one, set my transaction here, and then I add the signer there. Then I can just run add the transaction, and then I can do each step and get the status of the state machine in between each action. So if I just run this, okay, and you'll see that because it's a payment transaction, it has no return value. There's my transaction ID. You notice it went from building to built, signed, and committed. It didn't go to submitted because I didn't submit it. I just went straight to execute, saying I wanted to wait the results. So I didn't have a chance to log the status for it. Okay, from a method standpoint, looks very similar. Except I'm reading the contract, getting my ABI contract like you saw me do earlier. And then what I'm doing is I got this utility function that Ben wrote for me. It gets a method by name, and it returns an ABI method object. So I'm just doing a find, basically just loops through all in the contract's methods and tries to find that particular name and returns an ABI method for that particular method name. So the one I'm looking for is the add function, and I'm signing in the variable sum. So here's those common parameters you saw earlier, and here's where I'm doing the add method call. Here's my method, here's my method ABI method instance, and then my method args 1 and 5, and then I'm calling it. And that's really, and then I build the group, and I'm skipping all the other steps in the thing, going straight to execute. When you do execute, it runs through every state in the state machine and does those steps automatically. So you can skip all of the internals if you want to. All right, so if I put this in here, all right, you can see I added 1 and 5 and I got a 6. There's my result. There's the transaction ID, and you also get the raw values as well. And there's the, so that's pretty much all the results. Okay, I need to pick it up a little bit. So you've seen this code here. One of the things I want to talk about is the special types. Notice how what's different about that signature compared to the ones I've done before, is I have the word pay in the first transaction parameter for this signature, right? This method signature has the word pay. What that means is this requires a payment transaction if someone makes this call. So and you can see in that as a method parameter, when I actually call it with the SDK, I'm adding that transaction as one of the arguments to the method argument. You see that? Now let me show you what the composer does with that. And this is the beauty of the composer to me. It automatically creates the argument array, and in the first argument, it gives me my selector. Second argument, it gives me 10,000. Third argument gives me 1,000. And in addition, it creates an atomic group with a payment transaction first and a smart contract call second. And it creates that group for you all with the composer based on that signature. I think that's pretty daggone cool compared to the way we've had to do that. All right, so let's take a step further. Let's say I want to use a foreign type. I want to add an account to a call. Then you just add it as a parameter like you would anything else. And you'll notice the last parameter down there is an address. That says add that to the accounts array. Okay? Now, what does the composer do? Similar to what you saw before, adds my argument array. But now it also adds an account to the accounts array. The accounts array always has the sender in the first slot. And then finally, it builds the transaction group with a payment and an app call. Okay? Okay. Actually, I'll probably skip this one just because of time, but there is a full-fledged example here that, well, actually, let me just show you the code for it real quick. All right, so this is if you look, I'll give you a pointer to this code, and 2 pointers actually, but there's Ben wrote a full-fledged example that shows a bunch of different methods for doing different things. And the contract's actually built and written in this example code too. And so you can just go through it, show you how to add different methods, how the special types, the foreign types, that type of thing. So you'll get to take a look at that. Okay, so let's, I want to talk about the back-end side now. All right, you use the composer, you use the JSON artifacts and the classes associated with manipulating those. Now let's talk about, what do I do on the backside? Well, just so you know, most of what you're going to see here is it seems a little bit complex, but PyTeal, when we finish with it, PyTeal will make this much, much easier. But if you're going to handwrite TIL, you're going to need to know this. All right, so we have the method opcode. As I said, you got your method signature, the same one that we built in this previous example. I just want to call that method. I want to use the method opcode, and it converts that method signature to a method selector. Now let's compare it to the first argument to the TIL call, okay, to the smart contract call. And if it hits it, I just jump to that subroutine that implements that particular functionality. That's the method opcode. Now here's a couple example return values. I put some PyTeal examples there. Don't pay too much attention to them because that's more than likely will change. But on the right side, this is TIL that you will need to know. If you're returning, can y'all see? If you return an integer, you have to make sure that you convert it to a byte array. And now you do that with the I to B. And then you concatenate that onto that 4-byte prefix I told you about and log it out. For a byte array, you just concatenate the results of it. Okay? Now, finally, I'm going to talk about dynamic types because this is probably the most complex thing you'll do in TIL when you're dealing with the ABI. As I said, anything with a dynamic type means you don't know how big the object is going to be at the time of execution. So in this case, I got concat string, and it returns a void in my method signature. Then I know it takes a string. Well, the string can be arbitrary length, right? So that makes it a dynamic type. So what does app1's argument look like in the byte array? Well, the first 2 bytes of that argument will be the length of that particular string. Then right after those 2 bytes, then you'll have the start of the string till the end of the string. That's the byte structure. All right, so how would I get that length out? Well, you use the new extract opcodes. We have an extract uint16 that you can pop those 2 values off and convert. It converts to an integer, and you get the length of the particular string that you're dealing with. Okay, let's make it a little bit more complex. Let's say we have a 2-element string array. So now I have 2 dynamic pieces of data, right? So, but I know one thing. I know that the length is fixed at 2. So the first thing I'm going to have is the location of the first string, the first 2 bytes. The next 2 bytes will have the location of the second string. And then the first 2 bytes will point to this other location, which is the length of the first string. And then we have the start of the first string. And then somewhere further down there byte array, you get the pointer to the length of the second string, and then you get the start of the second string. Now, since this returns a string array, I got to deal with that too. You'll notice I'm just grabbing the location of the first string with that extract U16. All right, so now I have to return a value. If you're writing TIL, you need to make sure you prefix dynamic data with the lengths. Just like you saw it coming in, you need to return it that way. So the ABI knows how to handle that. The composer knows how to handle that. So we start with the length of the string. Then we give it the full string. Now, from a standpoint of TIL, this will change your return code a little bit. You notice I got my return bytes. I previously stored in an example the length of 2 strings I was concatenating. So I'm just adding the 2 of those together. I to B that because we need the byte array. And here's the trick. I to B returns 8 bytes. I only need 2 of them. So I just cut off the last 2, and those are the 2 that have the length in it. So I just extract those, concatenate those onto the end, load my result, concatenate that, and then log it out. And that's effectively how you return a string. Okay, the last one is the most complicated case, in my opinion. It's when you have basically a double unbounded array. All right, so how do you handle that? Well, the first thing it starts off with is the length of the array, because we don't know what it is. So we have to start with that. Then this is considered the start of the string array. Then what we get is the position of the first string, just like you saw from the other one, but it's from the start where you see that line. So if you're counting bytes, it'll be 2 bytes offset. Then the start of the second string, and then somewhere down there we have the length of the first string, and then this first string, and so on. You get that? That just gives me the length of the int 0 just gives me the length of the string array. So those are the key things, and that sounds complicated, but I'm going to show you a demo of what it looks like, and then we can ask questions. All right, so let me go to goal here. All right, so I have this complex piece of TIL that does this concatenation that you saw in my example. Instead of showing you that code, I'm actually going to debug it so you can see what it looks like from the stack level. All right, so I'm deploying it in Sandbox, and I'm now going to fire up a debug instance. All right, you notice here there's my inspect. That's just Chrome ://inspect. Click the inspect button. Can you read that? Let me slide this over just a tad. All right, so I'm going through my TIL code here. All right, it looks fairly complex, but it's not. This first bit of code just handles when I first deploy the contract. Now here is where I've got my method signature. It's a 2-string array, and I return a string. So the first thing I want to do is get that, compare those selectors. So if you look at the stack, you'll notice they're both the same. So it's actually calling the right method. And I assert here in case it didn't. Now the first thing I do is grab that big old string array of those 2 elements, the 2 strings, and I store that in a 0 scratch spot. I load it back up and I dupe it twice. So now I have that same string 3 times on the stack, and it'll be very obvious why in a minute. All right, the first thing I want to do now is set int 0, which points to this location right here. And I want to call extract U16 on that. And that tells me the start of the first string. It's the 4th byte. No, the 5th byte, actually, 0 to 4. 5th byte is the start of my first string. All right, then I'm going to dupe that. I'm going to skip to, and what does that tell me? The start of where the actual string data is at for the first string. All right, so now I know that 4 is where the length of it is. 6 is where the start of the string is. Okay, so I store the location of the first string, and now I'm extracting from 4 to, well, actually, hang on a second. I'm going to extract a uint16 so I get the length of the first string. And so right here, you can see it's 11 bytes long. So I'm going to store that 11 bytes. So now what I have stored is the location of the first string and the length of the first string. Next thing I do is load that up. The start of the string starts at byte 7. The length of it's 11. And then I use this new extract free opcode to pull out that first string. And you can see here, first string. And then I store that in the first slot. Got that? Now I'm not going to go through the second one, but it's essentially the same logic, except it just rips out the second string. So let me play to that. All right, the next thing I'm going to do is I'm going to load those first string and second string on the stack. And I'm going to concatenate those 2 because that's what this method does. Put those together, and I'm going to store that in a 0 scratch space. Here is my return prefix. You see this string right here, down here. Those are the bytes. Okay, and I'm going to load up the length of the first string because I stored it. Load up the length of the second string. So total is 23 bytes. Add those together. Then I'm going to I to B that because I have to convert it to a byte array. And that gives me this. And I'm only interested in those last 2 bytes. So I'm going to use this extract opcode to cut from the 6th byte to the 8th byte. Okay? So once I do that, it should give me the last 2 bytes of the length. I concatenate the length on, then I load the final result, and I concatenate that on, and then I log it out. That's effectively how you would concatenate 2 values and return it. And then I load a 1 on the stack and just return. So that's pretty much all there is to it. That seems complex, and PyTIL, I promise you, will make this much, much simpler. Everybody's going to start loving PyTIL. But so that's pretty much how that works. Now let me give you a location of where some of the more examples you can get at. and also a link to the presentation. All right, so take a screenshot of that if you want to do that real quick, because that's where we have a bunch of examples in TypeScript and Python. So if you want to get that, feel free to go ahead and do that. And then finally, here's a link to the presentation you just saw if anybody wants that. And I'm available for questions if anybody has any questions. By the way, it's been great having you guys at this conference. It's been a fantastic time.